Hi friends, welcome back in the series of FMT. So today we have another lecture, that is lecture 10 on FMT, which we will be doing a prediction on customer flight satisfaction, right? So we have data set which I'll provide the link in the description also. But how we can use that and how we can analyze all the test cases, we will see in this video. So let's see the context and defining problem statement. So basically the data that we have at hand is of passenger and their feedback regarding their flight experience. Each row is one passenger apart from the feedback from the customer across various attributes, like we have 15 in totals, like food, online support, cleanliness, all these. We have data about the customers, and that is age, loyalty to the airline, gender and class and all. So here our target column is the binary variable which tells us if the customer is satisfied or neutral, or we can say dissatisfied, right? Another is the task at hand is to analyze reason for customer satisfaction or dissatisfaction. So and finally we built a model to predict customer satisfaction using all or some of the data that we have. So here we have a step. So the first step is data loading and pre-processing that we will do. Then we will do exploratory data analysis. Then we will do model building and evaluation. Then we will do model tuning, and finally we will do the dimensionality reduction. So let's start with the very first step. So as this step will definitely help you whatever the project you are working with, like how to frame the problem statement, how to achieve our goal in steps, right? So first we load the data and we do the pre-processing part. So we import the pandas, numpy, pyplot, seaborn, all these library that we want, and we are ignoring our all warning, right? So here we are commenting the necessary thing that you need to know, like here we do not import warning always. So we use this just because to ignore or look our this Jupyter notebook very clean. Secondly, we import the data frame that are needed. So we have two data frame, basically flight data train CSV and survey data train CSV. So as I said, I'll be providing the link of this CSV file in the description also. So the first flight data train that is the data regarding customer attributes, and second is survey data, is the data regarding feedback from customers, right? Now we join the two data frame using the ID column as the primary key. Hope you know about the what all the keys that we have. So primary key basically represent the unique identity in our table. So we rename the ID column of one data frame so that their ID column name becomes same. So here we using pandas, we use join method, right? For example, c equals to a dot join b, so it will join two data frames on the ID column. Similarly, we are doing df equals to df2 dot set index. First we are setting the index as ID. Now we are joining df1 dot set index to the ID, right? So it will return us the newest data frame, or we can say the combination of both data frame. If we get the head of this data frame, so you can see that both the data frame has been merged, right? So here first df1 will be here, then df2 will be here, but as we combine them on the basis of ID, right? So here ID will be same. So here you can see satisfaction, seat comfort, these are all the attribute of the flight that the services have been provided in the flight, right? Online support and all these things. Then we have gender, customer type, age. So this table or this data frame is basically of customers, so we have merged that. Now using pandas, we use concatenate method, because the ID columns are not in the same order in two data frame. So first we sort them and then concatenate. So here a equals to df1 dot sort values by ID and b equals to df2 sort values by ID, right? So b is the reset indexing. So these are some terms that are very useful inside our journey towards AI, or we can say with the Python. So reset index, we drop true, right? In place is true, so it will reset the index so that it doesn't cause a problem while concatenating. Now that we are confident that both data frames are in the same order, drop the id column in the second data frame. So what we will do, b dot drop columns id in place true, right? Now in c we are again taking the concatenation of a and b x is 1, that means by column, so it is concatenated. Now if we print all these things, it will definitely get the data. Similarly, using pd dot merge, so we can also use it. So first we will take a copy of df1, then we will take a copy of df2. Now we will merge a dot merge of b, right? How we will merge that? We are telling this is left on join based on id, and right on join is based on id. Now but then we are dropping the column id. So again we will print all these things, we'll get the relevant values. So let's get forward. So our step 4 is basically print the number of missing value in each of the data columns. So we will do df dot isNA dot apply, so pd dot value count. So here isNA basically gives a boolean data frame, value counts give us number of trues and falses, right? Now here you can see that it will return the false values are these and true values are these. So we are getting all these, right, on the basis of value counts. Now we are doing df dot isNA dot sum. So here we are printing the sum of all the NA values in our df. So like departure dot arrival dot time convenient, we have 8244 null values, right? Or we can say NA values. So since true is 1 and false is 0, if you do a sum of a boolean data frame, we get a number of true in each columns, right? So here we get all sum. Now what we are doing, we are doing df dot isNull dot apply pd dot value count. So isNA and isNulls are exactly the same. So here you can see this time for true we got all the relevant NAs. Now the step 5 is drop all the rows having at least one missing values and check the shape of the data frame before and after dropping the rows. So fill null values in arrival delete minutes with mean, and after that drop all the rows with null values. So here you can see, since there are very less null values in the arrival delays minutes and this column, and let's impute with the mean. So how we can impute that? So just accessing the column, now filling NA with df dot mean values of this arrival delay in minutes, right? Now we are doing in places true, that will permanently be saved. So we have two ways here, alternate way we can say. One is we replace the np dot none with the main, right? Another is from scikit-learn we have simple imputer library. So what it will do, it will impute the missing values, or we can say the none values, right? And we are passing the strategy as mean. So we can do either way, whatever suits you. But guys, this is just for your knowledge. I am trying to cover all the concept or all the relevant concept, because we are about to end the series of FMT, although we will have the project on it, so I'll provide some hands-on as well. But here before that we need to know the basics of the FMT, right? Now df dot arrival min is NA, we are again getting that, but this time as we got 0 because we have imported all the NA with mean values. Now rest other missing values are filled with not captured, so it can be done in other way also, or also can be dropped according to the problem and business context, right? So it is as per required. So I am doing df dot fill NA not captured in place too. Now if we print df dot shape, so we have the shape of our main df. Then the second phase we have is the EDA, or we can say the exploratory data analysis, in which we do the we will be doing correlations, and we will be printing all the graphs and all. So first thing we are doing a df dot core, so it will basically show correlation of only variable here. So core if it is greater than 90%, so we will get that. So age right? Flight distance, departure minutes, arrival delay, so all these values we'll get here. Now to drop, we are getting departure delay in minutes. There is just one obvious correlation that we can see, that is between arrival delay and departure delay, right? So this is our departure delay and this is our arrival delay. So if you check the departure delay minutes, right, so here you can see the correlation here. Now feedback column, so basically we have seat comfort, all these feedback column in our data set. You can read them thoroughly. Now we manually encode these variable or the printed above, right, such that they follow an order based on the meaning. So example, we are assigning awful as 1, unpleasant as 2, decent as 3, good as 4, and great and 5. So we will do that. We can say the manual level encoding. So it is a bit of a subjective task, hence go ahead in the way you find appropriate, obviously. Now df dot replace, so extremely poor is 0, poor is 1, need improvement 2, acceptable 3, good 4, excellent 5, not captured, again we are passing as 2. So here we have given all these label to all our variable. Similarly, very inconvenient as 0, inconvenient as 1, inconvenient as 1, need improvement 2, meaningable 3, convenient 4, very convenient 5, right, all these label we have assigned. Now df of departure dot arrival time convenient, so here we are again doing the value count. So these are the value count of integer type. Display count plot of every feedback attribute with respect to customer satisfaction. So you can see sns dot count plot and set u satisfaction. Obviously we have seen that many times. So we can use Seaborn's count plot to plot a stacked bar chart. So bar chart, so sns dot count plot df dot seat comfort, we are doing on df dot satisfaction. plt dot legend loc, we are giving upper right, and b box to anchor 1.45 and 1, so to place the legend in a good position, right? So all these this we can see the matplotlib or the count plot that we get. So blue is for neutral or dissatisfaction, and orange is for satisfaction. So this is our seat comfort here, and this is our count here. Now since there are a lot of columns that we want to plot, we can put all of them in one plot by using subplot. So additionally, since there are a lot of subplot that need to be plotted, we can use a for loop for that. So plt dot figure size 30 by 20, position is 1. So we will use this variable to index each of the plot. Feedback is all our feedback terms here. Now we are looping that inside a for loop, right? So it will plot for each and every feedback, right? So here you can see that this is for seat comfort, departure, arrival time, inconvenient, food, drink, this is gate location, lightweight, and all the other rest of the thing. So here but here we have one more alternative way, that is bar plot. So we can easily do that. Plot dot figure size, we are passing position 1 and for I in feedback. So if you run that, you will get similarly that with the bar plot way, that you can now draw all the insight that you can frame from that plot. So green and orange bars are count of satisfied and dissatisfied customer. Obviously we have seen that green and orange above, right? Now hardly any people who rated highly for seat comfort were dissatisfied. So here we can see seat comfort. So for seat comfort, if we check that, yeah, this is the seat comfort, you can see, right? So people who rated highly, right, here you can see the 5, and for seat comfort dissatisfied, right? Now a similar case with respect to in-flight entertainment. In this case, having less entertainment seems to have caused far more dissatisfaction compared to bed seating. Now difference is observed in ease of online booking quite evidently. So all these terms you can match with the graph that we got. Now print the average feedback score. So when satisfaction columns equals satisfied and when satisfaction columns is not equals to satisfied. So feedback column that we have here, now we are grouping it by satisfaction dot main. So average rating of individual feedback attribute across satisfaction level, right? So here if we print that, we will get that neutral or dissatisfied. So we get all these values. So you can see that how we started getting the values using this method. Now satisfied, so for satisfied we are getting the satisfied value. Now next step is draw any insight that you can form the above value. So here using these value, we observe the extreme values, lower side for dissatisfaction and higher side for satisfaction. You can see that bed seats are a strong cause for customer dissatisfaction. So as per our analysis, if we get for bed seat, or we can say the sitting, if we check for seat comfort, so here you can see that. So for seat comfort, strong cause for customer dissatisfaction, right? Now time convenience doesn't seem to be that big of this deal. So time comfort, so you can see the convenient delay people have found, so there is not much difference between that. Dissatisfied customer had some bad experiences with food, but average food seems to satisfy most people, right? So if we take food and drink, so you can see that dissatisfied are 2.6 and satisfied are 2.9. Now gate location is totally irrelevant. So here you can see that more people are concerned about this gate location, right? Wi-Fi is quite a factor. On an average, having food Wi-Fi yielded customer satisfaction. So here you can see that, right? Now easy online booking facility seems to be very important for customer satisfaction. So easy online booking, right? Online support we can see. So this is for satisfaction. Now easy online booking facility seems to be very important for customer. Okay, in flight entertainment seems to be a deal breaker. So if we check for the flight entertainment, so you can see that most of the people are satisfied. Now achieve the following. So next step is print the number of people who are more than just satisfied with the in-flight entertainment and yet were dissatisfied overall. Print the number of people who are more than just satisfied with the in-flight entertainment and were satisfied overall. So here df dot in-flight entertainment dot value count. So all these value we get it here, right? These are in-flight entertainment, the name that we are getting. So these are the value for that. Now number of people who got entertainment well but were dissatisfied in the end. So we apply this method. So this way we got this as 10%. So this is nothing but just a mathematical expression with the data frame. Now number of customer who got entertained and were satisfied with the flight. Again the notation for mathematics. So we are accessing the in-flight entertainment that is greater than 3, right? And satisfaction is satisfied. So we are printing the percentage of that. So this is the 45.05%. Now create a new column which is the mean of ease of online booking, online boarding, online support, and name it average feedback of online services. So if online services has a bad rating, then what is the average rating of the other feedback attribute, and how does it impact the final satisfaction of customers? So online df we take it as df.log, right? So we are accessing for ease of online booking, online boarding, online support. So here we get it all the average feedback of online services. Now online df average feedback of online services dot value count. So there in this way you will get the average feedback of online services, right? So all these services, you might find that a lot of things had to go well to satisfy the customer when the only services had a bad rating. right? Now model building and evaluation, the very next step that we have. So we first encode the column gender, customer type, travel, class, satisfaction. So use manual encoding or other type of encoding, whatever we want. So here we use the manual, that is number of classes in each of the categorical attributes. So I in df dot column, so we use satisfaction 2, gender 2, customer type 3, travel 3, class 3. So df dot class value count, so business, eco plus, so all three are classes in our flights. Now manual economic manual encoding. So again we will replace all these by our easily understandable notation, that is loyal customer as 1, disloyal customer 0, business travel 1, personal travel 0, so on so forth. Now one hot encoding. Now one hot encoding, so df dot coded pd dot get dummies. First we take this df into that alternate method. What we can achieve is use category encoding. So we import basically the category encoders, right, .ce. Now columns, we pass all the columns that are required. Now categorical category encoding, we take the ce dot target encoder. So df dot calls, we fit the transform with the df dot calls, right? Second alternate is of course one hot encoding, so that we are also applying here. And if you want to check more about this, this is the link. You can learn more how the one hot encoding can be achieved. Now df coded dot column, so all these columns that we have, df coded dot head. So if we get off head of our encoded, so here you can see that satisfaction, seat comfort, departure. So we have labeled all these. Now we do the scaling. So we have two way, either we can use min max scaling, either we can use standard scaler. So basically min max scaling scales the data set such that all features values are in the same range, that is 0 1. Standard scaler is basically removes the mean and scales the data to unit variance, right? So again you can learn more about on the official website of scikit-learn. Now df dot coded column, so all these columns that we have coded here. Now here we are going to use standard scaler to scale our data. So we normally import this from sklearn.preprocessing, that is standard scaler. We are taking this into scalar variable. Now what all columns to scale. So I have prepared all columns expected one hot encoded columns and target columns, as scaling of target feature will not change anything as they already have value like 0 1 only. So here you can see that we are taking all these into columns to scale. Now we apply df coded calls to scale, scalar dot fit transform, right? Df coded of calls to scale to numpy. So we can do scalar dot fit or scalar dot transform, right? Now df coded minus scaling that we are so here basically df coded is basically scaling, xy is also that is being used for scaling, or we can say x train y train, we use that for scaling. So use the same instance in the test data, right? So we can say x test, y test. So df coded dot describe, now we are described to get the 5-point summary. We can say the count, mean, standard mean, interquartile ranges and maximum values. Now df coded dot head, so if we get head this time, so this way you can see that, right? So in df now we are storing the df coded. Now let's separate the column satisfaction from the rest of the column. So we create x and y. So how we can do that? So to drop, so hope you remember initially or the in previous steps we have assigned to drop. So we are going to drop highly correlated features which we have found before, as their features might affect our model. So to drop we have departure delay min, so which we have assigned previously. X equals to df dot drop column satisfaction and the departure delay in minute. So is separating the target and the rest variable. So y is df dot satisfaction here. Now we create a train and test data set. So obviously we will use a train train test split from sklearn.model selection. So xtrain xtest, ytrain ytest, train test split xy, random state is any integer, and stratify we are passing as this y here. Now y train dot value count. So for 1 we have this much of values, 0 we have this much of the value for the satisfaction. Now y test dot value count. So similarly we get the value counts for y test. If we try to access the data types of all the extremes, so here you can see most are the float, but online boarding is in gender is integer, customer type is int, travel and classes are int. Now we can print the accuracy as well. So print accuracy on test data using below method. So we use logistic regression model trained using all the attribute, then logistic regression model trained using only the feedback column, decision tree model trained using all the attribute, and random forest model trained using all the attributes. So first we will see the logistic regression. So logistic regression with only feedback columns. So here sklearn.linear model logistic regression. So logistic regression we are passing in it lr.fit xtrain ytrain. So prediction lr.predict xtest. So prediction from logistic regression, score 1 equals to lr.score xtest ytest. Now if we print the score 1, so here we get 0.82. Predicting customer satisfaction solely based on the feedback. So if we print all the feedback, so you can see here. Now logistic regression with only feedback column. So xtrain xtest, ytrain ytest, train test split. So x log feedback, y random state 1, stratify y. So lr we are storing logistic regression. So similarly here we use the logistic regression. So if we print the number of feature used, so we are getting 14 here, right? So you are getting this, we are fitting the logistic regression here. So here we are fitting this to logistic regression, right? Prediction lr.predict x score to lr.score. So we are getting number of feature use, that is 14. Accuracy in prediction customer satisfaction solely based on the feedback, so that is nearly 80%. Now decision tree. So here if we do the same with the help of decision trees, right, all these things. So decision tree accuracy we are getting 92%, random tree forest we are getting 94%. So we can say we are achieving the higher accuracy with the random forest classifier. Now print features and importance. So here for decision tree, of course, pd.series. So pd features importance xtrain, sort values in ascending in descending. So here you can see that we are getting all these series of the values, right? Now random forest. So here pd.series, rf.feature importance, xtrain column, right, and sort values. So here we are getting the values for all these. So if we randomly take the class, so okay, here for class you can see we are getting 0.038, or for age 0.031, and so on and so forth for other relevant values. You can check according to your requirement. So basically this is one example. If you have similar problem, how can you achieve that, right? So it could be a satisfaction of any product, a satisfaction of any service. So this depends on your data set and your requirement. Now we have the next step, that is model tuning, right? So basically here print cross validation score. So decision tree model trained using all the attribute, random forest model trained using all the attribute, and fine tuned using grid search random forest model. So here we are doing all these steps in below. Display all the scores above with their respective models in a single data frame. So of course we are doing cross validation score here. So we are importing model selection of cross validation score. So scores 5, so cross validation score of DT, XY, CV10 mean, right? So if we print this, we are getting 93% in case of random forest, right? So for that we are getting 94%, and parameter tuning using grid search. So doing it only for random forest, as the mean CV score is better in case of random forest. So if we do that, we import the grid search CV, we pass the parameter as it accept bootstrap, max depth, max features, min sample leaf, and estimators, right? And if we do the fit for a grid search CV while passing the random forest classifier and all these parameter with verbose and unjob, so after fitting it, we will get the best parameters for that. Now RF equals to random forest classifier, again passing the same method. So if we do that, so here you can see that we will get the 95% of accuracy. 95% of accuracy. Now we are taking data, that is techniques and scores, right? So to print the result in a better way, so we have technique that is so here basically we have used all these techniques and which techniques is performing best. So this way you will be able to get that, okay, in our problem statement this was the best technique that is very helpful. So if we check all these techniques like logistic regression, LR with only feedback column, decision tree, random forest, CV with DT, CV with RF and tuned RF, so we get the highest accuracy in terms of this tuned RF CV, right? So xtrain dot shape, again if we get that the shape of xtrain. Now dimensionality reduction, the last step that we have. So we perform the following task in the dimensionality reduction. First, we use PCA to reduce the number of dimensions such that the component capture 95% of the data. Then we train logistic regression, decision tree, and random forest using the principal components. Now we calculate the accuracy score for each of the models. Then we calculate the cross validation score for each of the above models trained using principal components. Now we need to scale the data before using PCA, which we have already done before. So here sklearn dot decomposition import PCA. So PCA equals to PCA of 10. So we are here initializing the PCA object. So if we do the PCA dot fit on xtrain, right? So then we do a fit of our xtrain into our decomposition, or we can say the PCA, right? Now xtrain PCA dot transform. So this is PCs for the train data, this is for test data, and if we print the shape separately, so you can see the shape, right, got differ. Now PCA dot explained variance. So here we are getting this array of explained variance, right? 3.89, 2.45, 2.10, 1.30, 1.04, then 0 0.99, 89, 0.78, 0.63, 5.54. Now we are doing LR or logistic regression, LR dot fit of xtrain of this PCA of our with our y train. Now scores 9, so LR dot score xtest dot PCA of y test. Similarly, we do the decision tree classifier and the random forest classifier. If we print the score 11, so here we are getting the 88%, right? Similarly, we are again doing logistic regression to check the cross validation score, and similarly for decision tree classifier, similarly for a random forest. So all you can also print all these, but here if I print all these together, so here you can see that the algorithm, logistic regression, decision tree, and which was the best. So if we talk about accuracy score, our random forest is performing best. For cross validation score, our again random forest is of course performing best. Now finally we have the pipeline, as we have also seen in the last video. So it is basically it will automate the simplify automate, and it will basically automate and simplify our process. So all these required we can say all these required the library that we'll be using for the pipeline. So numeric features we are storing here, feedback features we are storing here, other category columns we are storing here. Now we are having our transformer. So pipeline, right, for numeric transform, pipeline for feedback feature transform, pipeline for other category transform. And now finally we are having our preprocessors. So here you can see that first is adding into pipeline. So CLF1 equals to pipeline. So preprocessor classifier is random forest, bootstrap is true, maximum depth is 30, maximum features auto, minimum sample leaf 1, and estimator 10, right? Similarly, then we are taking the raw data. So here data equals to df2 dot set index id dot join df1 dot set index of id, getting x and y. So we are getting x1 and y1. So by drop, x is by dropping satisfaction and arrival data delay in minutes, and y1 by having a dummy of the satisfaction of the PD, right? So again splitting, the twin test is split. So x1 y1 random state and stratify as y. Now fitting the pipeline. So here if we do the clf dot fit x train y1, so here you can see the pipeline that we have the actual. So you can see the preprocessor, right? So the column transformer random for so the column transformer, right, pipeline, simple imputer, then similarly the random forest classifier. Now if we get the final score, so here you can see we are getting the 95% of the final score. So if we conclude this, so given some data, we have seen how to perform EDA for the data set. The data that we have was not entirely continuous or categorical. Hence, we improvised the analysis to draw insights. We use the same old bar chart, but the way we interrupted is unique to this problem. Beyond EDA, we have seen how to pre-process data and train supervised models with it. And we finally put all the steps in one place and built a pipeline using sklearn pipeline function you seen here, right? Now you can also explore more in it, like you can cluster different segment for of customer to get more insight about their behavior, right? Because we have the data of that, and create new features and select the best feature to improve your model fit further. So what is best for you, you can do that, you can explore it more. So but for today this is all. Hope this video helped you a lot, hope you are enjoying it, and hope you are able to frame your problems, your own problems, or any other analysis with the with these case studies. So yeah friend, this was all about this video. So let's meet in the next video. Till then, all the best. Thanks.